This video series introduces you to some of the features in Optim Development Studio that you can use to develop an application that uses pureQuery annotated methods. In the first two modules of this video series, you learned how to generate Java code and SQL for a table and how to modify and test the interface. You've also learned how to use the SQL Outline view to navigate between the SQL statements and Java source code. In this module, you'll learn how to gather SQL performance data and how to view it in the SQL Outline. You'll also learn how to bind the SQL for static execution. You can use the SQL Outline view to find out how well your SQL statements perform and quickly find the statements that need tuning. For example, from the Outline view you can use explain to get estimated performance based on what the database chooses for an access path. You can also gather real-time performance information while actually running the statements. Let's see how to do this here. First, you need to create a run configuration, a step that is required for collecting SQL performance data. In the Package Explorer, right-click the project folder and select Run as Run Configurations. Double-click pureQuery to create a new run configuration. Type a name for the configuration, then click the Search button. Select the class that contains the main method for your application. In this tutorial, you will run the test application Inventory Levels Data Test. This is a simple, lightweight application that runs the select statements in the Inventory Levels Data interface that returns all of the rows in the Inventory Levels table. In the Program Arguments field, type the JDBC connection URL, user ID, and password that are required to connect to the database. Click Apply and then click Run. See the results in the console view. To view the performance data for the SQL statements that ran, go to the SQL Outline view. Click the down arrow on the Show Performance or Explain Data button and select Performance Data. Now you will see columns that display performance data with values in milliseconds to the right of the SQL statements. If you don't see any data, you may need to refresh the pureQuery project. It is easy to find the slowest SQL statement when you have a small number of them. However, if you have a large number of statements, you can more easily find the underperforming statements with the table view by clicking this toggle button, which switches to a table view of the page. Click the head of the total time column twice to see this view of the data with the slowest statements at the top of the table. Click the Save Current Performance Data button before you edit or tune one or more statements and give this data set a name. In this case, we've named it Dynamic. You can then compare the performance of the old version of those statements with a subsequent performance run. Finally, to remove the performance data from the view, click on Hide Data. In this lesson, you will bind and run statically the SQL statements that are in the Inventory Levels Data interface. When accessing DB2 data, static SQL offers many advantages, including the potential for better performance, tighter security, and more consistency and stability for access paths. In the Package Explorer, locate the default.gemprops file in the pureQuery folder in your pureQuery test Java project. Double-click the file to open it for editing. On a blank line in the default.gemprops file, specify the package and name of the interface. You can type the package and name manually, or pureQuery can assist you by pressing Control Space. pureQuery will list the interfaces in this Java project. Double-click the name of the interface to include the name on the blank line. Type a space, an equal sign, and another space. Use Control Space to bring up a list of options and corresponding descriptions. Choose the Collection option to specify a package collection and type in a name, in this case, Go Sales. Then use Control Space to select the Root Package Name option and type in a name for that, in this case, Inv Level. Save the file and click Yes for the message that appears so that pureQuery can store these values into the implementation. When you bind the SQL that is in the interface, pureQuery's static binder utility looks in the implementation class for these values so that it knows how to create the database packages. Now you can go to the Database Packages tab of the SQL Outline view to review the contents and structure of the package that will be created when you bind. Although only one package appears in the view, by default you create 4 packages, one for each isolation level. However, each of the packages will have the same root name of inv level and the same SQL statements. To bind the package, right-click the name of the package and select Bind. Make sure you are connecting to the right database, and then click Finish. pureQuery runs the static binder utility and prints the output from that utility in the console view. Now you can look at the packages in the Data Source Explorer. To make them easy to find, you can do that directly from the SQL Outline view by right-clicking the name of the package and selecting Find in Data Source Explorer. The Data Source Explorer opens and expands the folders until it finds and highlights the packages. Now that static packages are created, you can run the SQL statements statically. You can then compare the data with the data that you captured when you ran the SQL statements dynamically. To do this, right-click the project folder and select Run As, Run Configurations. In the Run Configurations window, open the configuration that you used to capture the first set of performance data. In the VM Arguments field, make sure you specify execution mode equals static. Click Apply and then click Run. Now you can look at the new performance data results by going to the Database tab and selecting the down arrow here. In the SQL Outline view, select the Compare checkbox. Each column now contains a shaded column and a white column. The shaded columns on the left show the current performance data from the static run of the SQL statements. The white columns show the performance data from the previous dynamic run of the same SQL statements, the dataset that you had named Dynamic. By default, the view compares the time in milliseconds for the execution time of the statements. You don't have to do the math yourself to calculate the value difference or percentage difference. Use the Show field at the top of the view to get this information. When you click Difference, the shaded columns still show the current run, but the white columns show the difference between the times. For example, in the first statement, the current total time is 10.76, which is 4.14 milliseconds less than the dynamic run. When you select the percentage view, you can see that the static run is approximately 38% less time than the dynamic statement run. Note that there are many variables that can contribute to differences in performance runs, such as dynamic statements currently in the cache or the impact of other software on your machine. But if you are able to control these variables, this view should give you a good estimate of performance improvements between runs. We hope you've enjoyed this tutorial on developing a Java application that uses pureQuery annotated methods. Try it yourself by downloading Optim Development Studio today. Other resources to help you learn are listed here as well.